All right, so here is what our axle looks like. Pretty simple piece, kind of. Put it in the 4-jaw, got it spinning true. Then I went through and drilled and reamed a 3/8 hole. Now, then I went and I milled off a flat, from a milling machine. So the trick is, when we start looking at our stud screws, 4 is, we only have an 1/8 of an inch wall there, right? And it's not really, in my hand. And there we go. A bit of balance. So for an 1/8 of an inch wall, that's probably the set screw to use, but that's too small a set screw for what I want to do. And then even if I use 2, I just don't like it. What I want to use is this guy. So there was no way to do it. There was no way to do it with such a fin wall. So because these are gee shafts, how I did it is I held down. I left about 10 thou over the top of it, so that it'll be easy to get in and out. Now, the trick is we're not going to be able to really wiggle this back and forth any longer, so it just has to be able to go around and off pretty easily. And then what I think I'm going to do is weld some gears 1/4 inch over the top of that flap, and then I can use something like this, and that has, that'll be adequate, and that'll give you good clamp force. And it's almost too big, but I think that'll work out right. Put drill my hook careful like. All right, so when I weld on a thing, I'll probably tick it, just to be careful. All right, so this gives us a bit of an idea of speed that we're gonna achieve. Probably misses the speed we're now achieve. I think that'll be fine for a forklift. It's not like we're a race car or something. The tires still has, it's not running bad. The bolts aren't really tight yet because you got to keep cinching them in until the 2 plates touch. The hub was running perfectly true. So this is what our final configuration looks like. We had to cut a whole bunch of these little spacers. So the hub sits on a spacer, which rests against the inner race. The bearings are all self-contained. I have a such cover here so that I can take up any play this way, because I didn't really measure that hole position on all of them the same. I just kind of drilled it. I think it'll be close, but I didn't want to, that I can adjust, just got her that way. And you can see that despite all of my care, making this thing run perfectly true and, reaming it and being really careful, my motor still has a slight wobble. If you look carefully, that could have been introduced from welding. It could just be that I stop. It could be that, I don't know. So at any rate, the only thing I really have to worry about with the motor is that it doesn't rotate, because really its orientation is held with all of this. So really my motor mount is just going to be, it'll, get all 3 of those, but then it'll probably just be a single pin mount here, just so it doesn't rotate. But I think the speed will be fine. Taking a lot of work just to get to this point. And one other thing that I noticed, and I knew I was going to have to address it, I still have not mastered when I drill a through hole, through rod, through a thing like this. Somehow on 2 of these, the hole on the other side is just a touch off, so I'm gonna have to drill it bigger. It's annoying. I think what happens is when the drill bit hits the inside, it just, because it's a long thin drill bit and it's not supported for all of that length. So I think what happens is just the wobbles just a little bit and then goes at an angle. We're talking like a 32nd of an inch, but that's enough to screw you when you're putting a bolt through. So it really doesn't matter if these have a little bit of give in them. So I'll just drill those holes, or at least one, maybe both, a little bit bigger. All right, so now we have 3 more of those to do. A little bit, and mark my center line, and you can see this set through collar is really just a spacer at this point, because everything is jammed together as tight as it can get. I can still make these spacers a little bit smaller to give myself a little more room here, but I am right on the line of center. So I'm going to try to make these a little bit longer for the other one, but I don't know how much room I got to play with. Like, I'm tight. The other thought is this can resist a boatload of torque because it's, basically the D thing, and the shaft isn't going to spin even about the set screw. Is this overkill? I mean, labor-wise, it's a lot more work. Or can I get away with... the reason I kind of avoided this was twofold. One, it's a smaller shaft size, and these are pretty easy to introduce a wobble. I already got a wobble. Like, even Matt didn't solve my rigid coupling wobble problem. So now this would be a whole lot easier to work with, and I already have 4 of them. I don't know if they can transmit the same. They can't. They cannot transmit the same amount of torque as this design. Will they transmit the amount of torque that I need to be successful? I don't know. It's not a huge part to change later. Like, I can change the axle up pretty easy, but it would affect the motor mount positioning. All right, so we're going to try another take on this. We're going to simplify our design since we had that through-hole problem on a couple of those, and we needed a set screw collar to take up the slack. And we were kind of long and getting towards center, reevaluated everything, and we had a fucking wobble, right? So I've reevaluated everything. Instead of a set screw collar, I'm going to use this as my set screw collar. Now I have an adjustable thing, and I don't have to worry about the alignment of the second hole. In terms of that pretty complex shaft that we built last time, we've simplified it down to just this, 3/8 with 2 flats on it. Or 5/8, 3/8, 2 flats, right? So now my hub is adjustable, and as my magic, here it appears. What to do it for a while. So, that's big enough that it will go through the hole and hit the inner race, but not go through the bearing. So now we don't need a collar on the inside. We'll still need a collar on the outside. And we can use this to take up the slack. So basically, we've fixed every single problem and made the whole thing smaller significantly. And one of the other things is the motor, in that D shaft, the D hole that I made before with the mill and the weld, and it probably was the weld that threw off the hole. It was pretty tight going in, man. Like, I had to tap the motor in, and it was just, once you weld that top on there, there's no reworking that hole. As whatever. So I think that this will kind of fix everything. Here's my mock-up. Simplify all my designs. Also, in terms of 3/8 being able to transmit the power successfully with a set screw, it has to, because that's what the designer of that electric motor chose. They chose a 3/8 inch output shaft with a flat. So, the full torque of that motor, the 8.5 foot-pounds, has to be transmissible in a solid way through this. So I'm just going to go with them on it, and I think it'll be fine. And it makes my life a lot easier because that part's a whole lot less time to make than that contraction that I was making before. Right, so we've picked up at least another inch and a half here, which is perfect. This is all much tighter and less parts, This slides easily into there, which is nice, and where all of this spins true. The motor actually still has that same... We still have that same bit of wobble on the motor. So, I don't know, whatever. I'm beyond caring at this point. I just will not overly... if I were to bolt this solidly to a plate, and not give it any room to wiggle, where I could use a flexible coupling, that's what they're made for. But I'm just going to hold the motor loosely, just so it can't rotate. And this is the design I'm going to go with. So I'll take this back apart and use that as my template. That little bit of a wobble that I had on both of those shafts, it was suspiciously the same. I used the forge on both of those, and I did this when I was like 20. This was one of my very first machining projects. I was building a Gingrey shaper, and I had my own little aluminum foundry, and I made a couple of these face plates, and I threaded them myself, and This was a very early project, and I'm going to bet you that it's the Chuck's mount to this faceplate that gave me that same little bit of wobble on both of those shafts. So I'm going to switch over to a different forejaw and see if it happens on the next one. So the next stage is to get all the tandems on and to make sure, just as a sanity check, because it could be off, that everything rolls pretty well and that I don't have to add any kind of suspension to the frame or I don't have to tweak any of these in any direction. They can compensate for some. Also, they're pneumatic tires, so I could lower the pressure in one if I had to. So this is all spinning nice and true. The front, you got to go off the front of the dial, and the top. The back isn't really faced, so the back plate will have some wobble. And what a hound is when I put these rims on, and there's a fair amount. Those rims are not made very well. Which I suppose is to be expected because they were $6 for everything, right? So what that translates to is no matter how careful I was with all of this, which I was, those tires are still going to have a little bit of out of placement. I'll show you on that side in a second, or when I get the tire on this one. All right, so in general, this is how well the tires run, which is not bad. I can live with us, and it's not even inflated yet, so it might get a little bit better when it's inflated. Now, ironically, the tire that I ordered having you to begin with is the worst out of the four. And I don't know why that one's running so crappy. It's not in what I did. So maybe there's a piece of something stuck on the back of the faceplate. So we got to take that apart again. Those split hubs like that are no fun. It's annoying to line all those parts up and to clamp everything down. But I'll give it one more shot. Otherwise, I'm going to buy another tire for $6 and, see if this rim is just jacked somehow. And generally, we're okay like that one. I think I found the culprit, pate ridge, from where the original piece was. I never even looked at it, but that's 1/16 of an inch or something might could give me that wobble. Now there were burrs on the holes that went through. There was paint, but even after cleaning all that off, I don't know. I guess the rum's kind of okay. I might accept it, might not. Also, I hooked the motors up to the new shafts that I did on the different forejaw. They were better, but they still had a little bit of a wobble to them. It was probably half. A solid set screw collar that clamps all against one side. I mean, these kinds of rigid couplings, they seem like they always have some kind of misalignment. That's why they make the clamp style that wrap all the way around and have a slit in them. Out here, they just have a couple bolts that go through off center of the hole. That way the bore remains as true. And usually they're a little bit deeper too, so that they have a longer surface area for alignment. I'm going to consider that little bit of a wobble just a side effect of these. I'll still hunt and see if that faceplate has any variation, but I'm going to accept that as well. So the next stage of the test was to make sure that all of our tires were touching the ground, because that was not assured with weldments and such, and the way that I aligned them. All the tires seemed to be tracking pretty good and rolling well. So I think that we are acceptable on that front, which is good because of the way that I welded those mounts on. And hindsight, not really hindsight, but what I could have done a little bit differently. The reason I welded these on at such an early stage is because I was welding directly to the casing that had the bearings in it, and I didn't want to do any welding on this once the bearings were in, right? So what I could have done is welded this to a plate that went across, welded these to a plate, and then all my weldments to the casing itself were already complete. And then I could have adjusted and aligned and shimmed the plate at any angle and then welded the plate to this. It might have been a little bit stronger. It wouldn't have been hardly any more work. I thought I could probably get away with it this way, and it looks like I did. But it might have been worth adding a plate just in case anything had gone wrong. The thing that I could have done, and hopefully I don't have to, might have been smart though, is if you've ever seen how a lawnmower or a tractor or a power chair has their suspension, they have a solid suspension on one end, and then on the other, like I'd have another cross member about here, and then I'd have a pivot rod right here so that the back two tires could rotate. This entire frame section could rotate like this, about a pin right here. So that way, if there was any variations in the flooring, you could always keep more of your tires on track better than a rigid frame. That's kind of like the first level of suspension, like the easiest. But I use it on a lot of things, like even my big tractor, which you can't see due to the glare, and a lawnmower has that. So it must be a fairly good suspension system for simple frames. I'm going to try it with this. I can always add that feature in later. So the next logical step to take, we got two directions we could go. We can put the motors in and do the motor mounts, or we can start working on the mast. I had to return one of the maker motors, so I only have 3 right now because one had a bad bearing and was making crunchity crunch. So I don't know. I might still mount. I guess the next logical thing to do is to mount the 2 front motors, because I want to assure their positioning before, and then I can work around it with any of the mast stuff and with the actuators and stuff for the mast. So I think putting on those 2 front motors is a good next step. And then we'll do a mast. Well, I realize I'm showing you the intricacies of a lot of these setups. I could just show you kind of bulk points, but I feel like you have to understand what you're getting into if you're going to start a project like this, and understanding all those tiny little things that you wouldn't think about until you're actually in the throes of a project like this. So if I cover more details on why my wheel is having a wobble, or how much wobble it has, or how to absorb the thrust in the bearings, if you're actually going to build something like this, you want to know all those points, even if it makes the videos kind of long. All right, so we're making the motor mounts, and I just found a big washer. It's like a 1-inch washer, and the whole pattern is 25 millimeters as I measured it. Usually used like that clear plastic trick, but I always get one hole that doesn't quite align because it shifts around. So I figured I'd experiment. I bought this on eBay for like $100 or something with a chuff. It's doing a great job. Like all of those lined up perfectly. So basically, I bolted it down to the table. At first, I put a pin in it, rotated it around. I'm like 6 thou off total. I don't care right now. I'm not going to bother recentering that. So I put this into my drill chuck. This is a center finder, and you can tell when it's a little bit off. And then with those completely tight, lowered this down in until it was right in there, and then adjusted the table around until it was, concentric all the way around. Zeroed out my digital readout, which you probably can't read right now, and then moved it to 25 millimeters in one direction. Well, and now I'm just going through and, putting the washer on there, cranking the jaws out to get it tight. Then all I have to do is just come down, mark it, spin it 12 times, blah, blah. But the holes are coming out great, so I'll deal with it. All right, so here is our range of motor collisions for right and left sides. That's too low. That would be okay. That would be okay for the front. That would be okay for the front. That would probably be the lowest. So, there is a difference in how these motors are going to be positioned. And in the back, I have to consider that we're going to have a battery box somewhere, and how high do we want it? We kind of want a low center of gravity. Our battery's obviously not going to be down under the frame or, lower. I don't know if we're going to be able to really rig that, because we also want to use the battery as, weight. So that's kind of pointing us at having a high center of gravity now, unless we did it in the center. And then in the front, we're going to have a little mount in the center here for our mast control back and forward. And we'll have to also have another control for up and down. So we don't want to encroach on any of that space, but I think most of that will be out here or centered. I'll play with it, see what works. If on how low I'm going to allow the motors to go is mast, what's going to be the lowest point on the thing, and it's probably going to be the mast, because I don't want the forks to drop more than they have to. So let's see, that's a 3.5-inch spacing. It seems a little high, but I also don't want the actuator for the mast to be, I'm thinking I want both actuators to work off of this bottom plate, and that will put the pivot up here, so there'll be that much leverage for it to work. I'll have a full 2 inches of travel, which is going to be a lot, actually. Maybe I'll buy a 1-inch actuator, because with that much leverage, 2 inches is going to be, and I don't want it to ever conflict, and I also don't want it to be too far out, right? Because there I lose more leverage. But the more of an angle it gets to, the more of a gap I need here for the clearance. And I'm going to have to beef up this bottom member to support both the vertical and the horizontal. And then I'll probably beef it up the sides off of that when I put in the mount. So I think that is the motor orientation that I'll use. It gives me the most room down on the bottom to work with things, and there's really nothing that has to be in that space. And I can do that in the back as well, because that takes up the least amount of space this way, so I can get the battery. Must I put the battery higher, or I could build a little carriage off the back. I could even extend it a little bit more for the battery. That'll work. Also, I measured, and I am 24 inches outside to outside, or 22 inches, sorry. And my crawl space, it's actually like 26 or 28 inches wide, the entryway. So this is basically right to scale. It'll just squeeze in there. And now I'm looking at it, those tires, like, this is pretty much like an all-terrain forklift, that is an awful lot of clearance right there. I don't have to deal with that much clearance. I could probably use smaller tires if I wanted to. Except I already built the hub specifically for those tires, and they seemed like a good size, but now they're looking a little bit big. But I'll probably live with it.